Hello, I'm Saif Ahmed and I'm going to solve this question, which says at time t equals 0 years, a forest preserve has a population of 1,500 deer. If the rate of growth of the population is modeled by rt equals 2000 e to the power 0.23 t deer per year, what is the population at time t3? Since this is the rate of growth, the integration of this will give us the population number. So the integration of 2000 e to the power 0.23 t from t0 till t3 will give us the population number from 0 to 3. So let's integrate this. We'll move the 2000 outside. We'll have e to the power 0.23 t. Again, 2000. The integration of this is basically e to the power 0.23 t divided by 0.23 from 0 to 3. So this will be 2000 times e to the power 0.23 times 3 over 0.23 minus e to the power 0.23 x0 times 0.23. This will give us, using the calculator, this is it will give us 8641 point, or let's write it, 0.004637. This is the population from T0 till T3. But as we can see in the question, at T0 the population was 1,500. So we should add it here also. Let's add 1,500 to this one, plus 1,500. It will give us 10,141.00464, which means that the answer is D. Thank you.
Now I will explain the objective of net change and motion. First of all, what is net change? One example of net change is velocity. The net change of velocity will give us the displacement, and the net change of acceleration will give us velocity, and we have so many other net changes, but for this question, the question we will solve now, we will focus on velocity and displacement and position. The question says a particle moves along a line with velocity v of t for 9 seconds. What is the total distance? First of all, we know that the total distance is represented by what? Represented by the integration of absolute value of v of t from a to b. In this case, we know that's from 9 seconds, so it is from a to so a would be equal to 0 and a would be equal to 9, absolute value of v of t. As y is as y there is absolute value, because in the graph of of the velocity, it may go below x-axis, and as it goes below x-axis, it moves for some distance, but it will be negative. So we must take absolute value of this negative, so we can have a positive value. So we can sum all of the and that's how we find the total distance of any function, of any velocity function. For this objective we will talk about net change again, but for other problems such as population growth and gallons pumped, or people leaving or entering a mall, and so on. For our example, we have this question, which is at time t equal to 0, a forest has a population of 1,500 deer. If the rate of growth of this population is modeled by r of t equal to 2000 times e to the power of 0.23 deer per year, what is the population at t equal to 3? The total population will be equal to what? The initial population plus the integration from 0 to 3, or the integration of the rate of change from 0 to 3. So we have the initial, which is equal to 1,500, plus the integration of 0 to 3 of 2,000 times e to the power of 0.23 t. The integration of 2,000 times 0.23 be what? 1,500 plus 1,500 plus. But here we will divide by the power. So it will be 2,000 divided by 0.23 times e, which is itself from 0 to 3. We'll substitute. So this function, by substituting 3 in t, what will it be? Minus the minus 2000 over 0.23, because the e to the power of 0 would be 1, so no difference. It will be here 1,500 plus. By using calculator, we found that this integration is equal to 8,641. So the total will be equal to 10,141. And this is how we solve it. And thank you.
Hello, I'm Saif Ahmed, and now I'm going to solve this question, which asks about the particle position at the time c here. And we know that the initial position was 30. To find the particle position at t equals c, first we should find the displacement. The displacement is the area under the graph. If it was above the x-axis, we will add, and below the x-axis we will subtract. So let's start by here. -4 plus 5 minus 24, which gives us -23. This is the displacement from t0 till t equals c. And the initial position was 30, so let's start 30 minus the displacement 23, or adding the displacement actually, we will get 7. This is the final position of the particle, so the answer will be B.
Now we again with the net chart of motion with other problems. Like here we can see the people. We have a graph about showing the people who come to the shop afternoon, yes, and it's written here that afternoon there was 2,000 people, and here we have an equation for the leaving, okay, and here the entrance and like that. Okay, first of all we take the areas. Here we have an area of here to 2, yes, here all to 2, here trapezoid, and here from 5. It's not accurate, but it's like that, from 5. And here is 3 trapezoid, here rectangle, here and trapezoid. Okay, first of all, area of trapezoid, okay, will be 500 plus 200 over 2 multiplied by 2 will be 700. Here area of rectangle, it is 500 also times 3, it is 1.5 here like that. And here area of trapezoid by 2 equal to 500 plus 300 over 2 times 2, it is equal to 800. Okay, the total here we can see that it is 3000 total. Yes, here 3000. Okay, now we can see that 2000 plus 3000 equal to 5000. And now the leaving that we use that equation, we integrate it from 0 to 7. Okay, here 1 second, integration 0, and the equation of dt that it is 4t2 plus t squared e negative t over 4. Okay, and from the calculator that we get 1871. Yes, 1871. And this we subtract from this, so 5000 minus 1871 equal to 3129 people. And that's it. And now again with net change and motion problems, acceleration and velocity. Okay, we know that acceleration have the integration of the acceleration is the velocity, and integration of velocity is displacement or distance. Okay, and the derivative and like that. Okay, we have a question that give us an equation of velocity Vt equals t squared for 3. Okay, and t is okay 0, and it is from the interval t to 0 to 3. Okay, and it's the question on the displacement. Okay, the displacement from 0 to 3, the time from 0 to 3. Okay, first of all, we have to get the zeros from this equation. T squared minus 4 cube equal to 0. We know that is t equal to 0, and here t squared minus 4 cube equal to 0. Here cubic root, we'll get t squared minus 4 equal to 0, and then it will be t equals plus minus 2. So we have now the zeros, t equal to 0 and t equal to 2. So So the derivative that it is the distance ct equal the derivative from 0 to 3 vt dt. Okay, so we can get it from 0 to 2 by negative and t square minus 4 3 dt by negative because it is when we draw the graph it is under the graph, so it is negative, and here it's positive from 2 to 3 cube dt. Okay, here we can directly calculate by the calculator, and we can use the u substitution. U substitution will take a time, but with u substitution we can substitute here t squared minus 4, and then du will be 2 t, then we cancel t with t, 2 will go out, and like that, and the boundaries will change, and we can solve, and we can solve it by calculator directly. Will be here 32 plus 78.11.125 will be 110.125 meter maybe, and this is the answer of the question that acceleration, velocity, distance, net charge, motion problems.
Here again with another objective. Problems on velocity, acceleration and displacement. This question is pretty simple and you can do it very fast. I did it twice, you can see, but here there's a different way. Question 13. Since here they just want to use you, since they only want you to get the velocity or acceleration or displacement, you can set away just by doing the integration. No need to do your substitution because it doesn't want you to do it. But if it wants you, you need to do the substitution or the permission. The integration from 0 to 3, but absolute value since it wants the total distance. We can implement it on the calculator to get the distance. We just get it by calculator, the integration of this, and you'll get 110.125 or 881 over 8.
I will solve the sixth question from the systematic quiz multiple choice, which is about net change and motion problems of acceleration, velocity, displacement, and distance. So the question says a particle moves along the x-axis. Its initial position at t is equal to 0. Second is s at time 0 is equal to 30. The figure above shows the graph of the particle's velocity vt. The numbers are the areas of the enclosed regions, which is the particle's position s at t is equal to c. So first we will start from t equals 0, which is 30, minus 40. It is minus 40 because 4 is below the x-axis, and plus 5. It's plus because it is above the x-axis, and then minus 24. It is minus because it is also below the x-axis. It will give us the result 7. So the position is 7. I will solve the fourth question, which is from the systematic quiz multiple choice. I will read out the question. It says, at time t equal to 0 years, a forest preserve has a population of 1,500 deer. If the rate of growth of the population is modeled by RT is equal to 2,000 times e to the power of 0.23 times t deer per year, what is the population at time t is equal to 3? So first, it will be, we will find out the integration from 0 to 3 for 2,000 times e to the power of 0.23 t dt. It will give us 8,000 641. Then we will add the population from t is equal to 0 years, which is 1500, which will finally give us 10,141, which is the final answer. We'll solve question number 13 from the system-wide quiz, which is from the objective net change and motion problems. The question says a particle moves along the x-axis so that its velocity at time t more than 0 is given by vt is equal to t times t square minus 4 or in the bracket cube. Find the total distance traveled by the particle from t is equal to 0 to t is equal to 3. So to be 0 from 0 to 3, t times t square minus 4 cube dt. Using the graphic calculator, we could find the zeros, and it will show using the graphic calculator that it will be negative from 0 to 2, as it will be below the x-axis. And positive from 2 to 3, as it will be above x-axis. Then we'll consider this as u, t square minus 4, and its derivative will be 2t dt. Then we'll find the total distance, which is minus 1 over 2, 0 to 2 u cube 2t dt plus 1 over 2 2 to 3 u cube 2t dt. Then it will be minus 1 over 8 u power 4 from negative 4 to 0 plus 1 over 8 u4 to power 4 from 0 to 5. Finally, it will be 32 plus 625 over 8, which will give us 110.125. In question number 13, which we have solved, which is about the 8th objective which is about net change and motion problems. We have used ideas from the first objective, which is U substitution. We have considered t square minus 4 as U, and we have found its derivative 2t times dt, so that it can make our work out more easier, and to get our result faster.
Welcome to the last video of the systematic quiz homework punishment, which is solving for other net change problems, which is question 12 from systematic quiz exam term 2. The question is that from noon until 7 p.m. the rate which people enter a shopping mall at time t given by ET, which is this graph, and the line is ET, where t equals 0 corresponds to noon and t equals 7 is at 7 p.m. This is the equation. L of t is this. If 2,000 people are in the mall at noon, how many people are in the mall at 7 p.m.? First, we need to find the total number of people in the mall, and then we subtract from the people left, because this equation L of t is the leaving rate of people from noon until 7 p.m. So first we need to find the number of people who are at the mall at all these areas. We can separate it to make easier, which is the first part here, trapezoid. So trapezoidal area from trapezoid, which is from noon until 2. We'll get the area, which is 200 plus 500 divided by 2 times 2, where we will get 700, because here we get 350 times 1, so 700. The second area, which is square, or rectangle, which is here, it's 2 to 5, so 3 times from 0 to 5, so 500, so 1,500. The last part also trapezoid, which is 500 plus 300 divided by 2, which is 400 times also 2, which is 800. So these, which is all of these equals to 3,000 people. So 3,000 people were at the mall from noon to 7 p.m. People who left, we need to find from the equation of the integration, which is from 0 to 7, 42 plus t squared times e power minus t over 4. So we can use here the calculator easily. Substituting the limits from 0 to 7, we get 1,871 people. These are the number who left. But they said to us 2,000 people are in the mall, excluding the 3,000. So 2,000 extra people entered other than the total number, which is 3,000, entered the mall. and we need to find the total number of people after leaving at 7 p.m., which means the total is 3,000 plus 2,000 minus who left 1,871. So who's left 3,129 people. And this is all the pre-response for the system-wide quiz homework punishment. Hope you understood the videos. Any questions, let me know.
Hey guys, I'm here with you with another objective. Net change other problems. Question 12 from the system-wide quiz paper. As you can see from the graph which is given from the question, we have these different areas from the interval 0 to 2, from 2 to 5, and from 5 to 8. First, as they give us the function for the people who are leaving, we just calculate the integration by calculator, as you can see, which is very easy. The integration from the interval 0 to 7, for 7 is the final, and this will end up being 1,851 people. Now, from these intervals, we got these areas. From 0 to 2, 700 people. From 2 to 5, 1,500. From 5 to 8, 800. We add them all together, we end up by 5,000. Then the final count. The initial, which is given in the question, 2,000, plus the coming, which you got from here, 3,000, minus the leaving, which you got from the integration of this function, which is 3,129 people.